Good day, ECO231 students. This week presents the start of a broader theme of market structures and competitive strategy. Now, the pricing and output decisions of firms depends on such market structures. So, for the most part, you've only encountered perfectly competitive market structures, but there's also oligopoly, monopoly, monopolistic competition, for instance. Now, chapters 10 and 11 examines this and the market power of such firms in particular. Now, for this week, week 10, we are only going to examine sections 10.1 and 10.2 of this chapter. Also take note that in this chapter, sections 10.4 and 10.7 is not prescribed. And then within 10.1 and 10.2, the following topics are excluded. They are dealt with in third year microeconomics. So, up until now, as I've said, you've mainly been dealing with your perfectly competitive markets, and you know that this type of market structure is characterized by many buyers and many sellers. So, no participant can influence the market price. We know that they're all price takers. Us as the consumer, we take the prices given and we decide based on that how much we are willing to buy. Now, in chapter 10, you are going to deal with monopoly and monopsony. Now, here you have the opposite of perfect competition. So, if you think of a spectrum, and on the one side you have perfect competition, on the other side you have monopoly, and everything in between that would be your oligopolies and monopolistic competition. So, monopoly and perfect competition, two sides on the opposite side of a spectrum. Now, a monopoly is a market where you only have one seller, right? But many buyers. And a monopsony is a market where you have one buyer, but lots of sellers. Now, for this week, we're only going to focus on monopoly and monopoly power. Next week, you will be introduced to monopsony. Now, a monopolist, you know, is a sole producer of a product. And you know from first year, your ECO151, that the demand curve a monopolist faces is the market demand curve. So you should also recall from your first year micro that the monopolist price tends to be higher than what would have prevailed under a competitive market situation, and the output also tends to be lower. So firms that have this ability to affect the price in such a way have what we call market power, and that is the ability of a seller or a buyer to affect the price of a good. So although a monopolist, as we've now said, essentially controls the market, the output for sale, and hence can determine the price, the monopolist is still constrained by the market demand for a product. So it must consider the market demand, that downward sloping market demand curve, and the cost of the product when it's going to decide how much to sell. So the price is then going to be taken from the demand curve if it focuses on the output that it's going to sell, or if it decides on the price, then the quantity sold follows from that demand curve. Ultimately, the goal is to maximize profits. So let's have a look at this table, table 10.1, and it's for a firm facing a demand curve given by P, which is your price, is equal to 6 minus Q. Now, in the table, we have price and it's given in dollars. That's the first column. Then we have the quantity that is sold, right, at these given prices. Then we also have total revenue. And in order to get total revenue, you get the product of your price times your quantity That would yield total revenue. And then lastly, we have marginal revenue and average revenue. And we are going to see the relationship between these three columns. So let's have a look. When price is $6, output or the quantity is going to be 0. Hence, total revenue, which is price times quantity, is going to be 0 as well. So, as I said, in order to get your total revenue, you would say your price times your quantity or your output. So, for instance, here we've got a price of $5 times 1 gives you a total revenue of 5. Here we have a price of $4 times a quantity of 2 that gives you a total revenue of 8. 3 times 3 gives you a total revenue of 9, and so on. Notice that as price falls, you see the units of output is increasing. So as it falls from 6 to 5, from 5 to 4, the quantity in this example, based on this demand curve, the quantity increases from 0 to 1, 1 to 2, 2 to 3, etc. Another thing to take note of is that when, for instance, when price was $5 and quantity was 1, we saw that total revenue was 5. When the price was $4 and the quantity increased by 1 unit to 2, the total revenue was $8. So you saw that your quantity increased from 1 to 2 units, and this was when price fell by from 5 to 4. But if we zoom in on the relationship between total revenue and the change in quantity, if we reflect on the change in total revenue that comes about due to quantity increasing by 1 unit, we see that the change in total revenue is 8 minus 5, it is 3, and the change in quantity was 1. Now, the change in TR over your change in your quantity gives you your marginal revenue. Now, if we look at between the second and the third unit, the quantity increases by 1 unit, we see that total revenue only increases by $1. Hence, your marginal revenue, which is the change in your total revenue, over your change in your quantity, it is going to be equal to 1. So we can also see that total revenue, it increases up to a maximum of $9. That is for the third unit of output. Thereafter, as the quantity increases, total revenue begins to fall, it declines. Now notice what happens when total revenue declines. We see that marginal revenue has in fact become negative. So therefore, we can see that when total revenue is increasing, marginal revenue is positive. However, when total revenue declines, marginal revenue becomes negative. Now, also we can see that average revenue is obtained by saying total revenue divided by quantity. So if I say 9, my total revenue divided by 3, I would get an average revenue of 3. If I were to say 5 divided by 5, I would get 1. So in order to get your average revenue, it is your total revenue divided by your quantity. Take note that your average revenue is greater than your marginal revenue. That is important to note. Average revenue is also equal to our price, as we can see in this table. Now, if we go on to figure 10.1, 10.1 shows the various curves, so your average revenue and marginal revenue, plotted using the information from the previous table. So on your vertical axis, we've got dollars per unit of output, and on your horizontal axis, we have output. Now, see that marginal revenue has this much steeper slope than your average revenue, and your average revenue curve is also the demand curve. So this is for a monopolist. So having reviewed that the monopolist average revenue curve is also your downward sloping demand curve, and the question now becomes, what output should your monopolist produce? And figure 10.2 presents the monopolist's output decision. So remember that your profit maximizing rule states that profit is maximized where marginal revenue equals marginal cost. So this also holds for your monopolist. So in this figure, it's going to show us that profit is going to be maximized where marginal revenue equals marginal cost. So on our vertical axis, we have price, and on our horizontal axis, we have quantity. Now, in this figure, you have your marginal revenue curve and you have your demand curve or your market demand, which is also your average revenue, and your marginal revenue curve lies below this curve. You also have your marginal cost curve and your average cost curve, and these cost curves were shown to you in chapter 7. Now we can see that at an output of Q star, that is where marginal revenue, which is this blue curve, and marginal cost are equal. At that point, at Q star, that is the output level at which these two curves intersect. So now we need to ask ourselves, what price will be charged? So now trace your finger up to the demand curve, and you will see that at an output of Q star, the price that the monopolist will charge is given by P star. Now, how do we know that this is going to be the output that will maximize profit? Now, let's say an output of Q1 was chosen. In this scenario, if you compare marginal revenue and marginal cost for Q1 is at this point, however, marginal revenue lies above that. So MR is greater than MC for this output. So this yellow shaded area represents lost profit from producing too little. And if you were to sell more or to increase output to Q star, then profit could be increased. However, if we look at the next shaded area, this yellow shaded area, if output were Q2, now that output, if we compare the marginal revenue at that point and marginal cost, we can see marginal cost lies above marginal revenue. So this difference between marginal cost and marginal revenue, MC is greater than MR, that also represents lost profit from producing too much now. So if you were to reduce what is being produced to Q star, then this lost profit would be minimized and profit would be maximized at Q star. So just some algebra to recap. So we can see algebraically that Q star is the output that maximizes profit. Profit, we know, is the difference between our revenue and cost. And all of these are a function of output Q. As Q increases from 0, we saw that profit will increase until it reaches a maximum. Then it will begin to decrease. So the profit maximizing output Q is the level of output such that the incremental profit resulting from a small increase in Q is 0. So algebraically, that represents that incremental profit resulting from a small change in Q is 0. Or we can see that this represents that incremental revenue from a small change in Q minus that incremental cost from a small change in Q. But this is also marginal revenue minus marginal cost. So therefore, it can be written as marginal revenue minus marginal cost is equal to 0, or marginal revenue is equal to marginal cost. And this is the profit maximizing condition. We will continue with this example in the next audio.